Hello and welcome to Cambridge Advanced Level Mathematics, here the channel where we practice past examination questions from previous years. Today I brought you question 7 from paper 3 of 2022. It's a question on complex numbers, and those of you who watched my video, the previous video, I dealt with complex numbers and we discussed the standard form of a complex number, we discussed the exponential form of a complex number, and we also discussed the modulus and the magnitude of a complex number. Now, question 7 is a question that is entirely on complex numbers, and it says here, u is equal to root of 2 minus a root 2i divided by 1 plus 2i. First question says, express u in the form x plus iy. In other words, express u in a form which is free of fractions. Question B says, if a is equal to 3, express u in the form r e to the power I theta. R, of course, will be the magnitude or the modulus of z, and theta is the argument of z. Finally, find the two roots of u. Okay, so let's write our u nicely over here. So u is equal to the root of 2 minus a root of 2i divided by 1 plus 2i. How do we get rid of the fraction? We multiply the top and the bottom by the conjugate, the complex conjugate of the denominator. So that gives us root of 2 minus a root of 2i in brackets multiplied by 1 minus 2i, all this over 1 plus 2i multiplied by 1 minus 2i. Notice what we did. We multiplied the denominator and the numerator by the complex conjugate of the denominator. The complex conjugate is you simply change the sign here immediately before the imaginary part. If it was minus, it would then become plus, but it is plus here, so the complex conjugate is 1 minus 2i. Let's simplify. We get root of 2 times 1 is root of 2. Root of 2 times minus 2i, we get minus 2 root of 2i. Okay? Right, so we're done with that. Minus a root of 2i multiplied by minus 2i should give us this minus sign, and what minus sign give us a plus. Then the I and the I will give us a minus. So the answer will be a minus, which is minus 2a root of 2. The I disappears. Finally, then we have this and that. We skipped one, didn't we? We skipped this one here. We skipped this times that, didn't we? Okay, so we have minus a root of 2i times 1 is minus a root of 2i. Okay, and then of course when we multiply this one, we got 2a root of 2 and the I disappears. Okay, let's sure we get that right. We multiply this by 1, we get root of 2. We multiply this one by minus 2, we get it minus 2 root 2i. Then we multiply this by 1, we get that. And we multiply this by that, we get minus 2a root 2. Let's get downstairs. Here, downstairs, what's happening? 1 times 1 is 1. 1 times minus 2i is minus 2i. 2i times 1 is plus 2i. 2i times minus 2i, this minus and plus gives us a minus, and the minus that comes from multiplying I by itself will also give us a minus 1. So there are two minuses giving us a plus 4. Okay, are you sure about that? So it's 2 times minus 2 is minus 4. Minus I times I is minus 1. So it's like minus 4 times minus 1, which is plus 4. Let's simplify and put all the real parts together and the imaginary parts together. So this is real, this is real. So we have root of 2 minus 2a root of 2, which is this one there. That's the real part. Minus I bracket. This one here is imaginary. So we have a root of 2 and this one here plus 2 root of 2. So the imaginary parts are this one, which is that, this one, which is that. Okay, and of course our denominator is this cancels with that, and we're left with 1 plus 4, which is 5. So there's a 5 here, and there is also a 5 there. So this complex number is now in the form x plus iy, where y is this part here, and the x is this part here. I think if I remember well, this was given 3 marks. One has to be very, very careful in multiplying this out. The test will be mostly in handling your eyes and the associated negative and positive signs that go with it. So now let's go to question B. B says if A is equal to 3, express U in the form that. First of all, let's put 3 for A. So here we will have root of 2 minus 2 times 3 is 6 root of 2 divided by 5. Over here we have our I. This is A is 3, so it's 3 root of 2 plus 2 root of 2 there, or divided by 5. 1 root of 2 minus 6 root of 2 is equal to minus 5 root of 2, of course, divided by this 5. Over here, you have a minus I there, but inside here it's 3 root of 2 plus 2 root of 2, which is 5 root of 2 divided by 5, of course. And this simplifies to minus root of 2 minus root of 2i, full stop. That is your U when A is equal to 2. But we are not yet there, because we are supposed to express this in the form r e to the power I theta. In other words, r will be our modulus and theta will be our argument. So let's draw a nice little Argand diagram here to represent our root, our complex number U. Okay, so here is the Argand diagram. Of course, this is our real axis. This is our imaginary axis. So x is minus root of 2, which is perhaps, let's say it's somewhere there. And our y is also minus root of 2. So perhaps, let's say it's minus there. So our complex number is in the third quadrant. So which means our theta, which is the argument, is there. It is minus something. Now, we know that, first of all, our r, which is the modulus, will be given, if it is x, y, r is given by square of x plus square of y, or under the square root. But in this case, x is minus root of 2, y is minus root of 2. So this gives us the root of minus root of 2 squared plus bracket minus root of 2 squared, which of course is just root of 2, which is 2 plus 2, which is root of 4, which is equal to 2. So r is equal to 2. We can write u, modulus of u is equal to 2. Okay? What about the argument? Now, we know that theta I should have written theta first of all. I'm writing tan of theta. We know that theta is equal to arctan y over x, which in this case is arctan bracket minus root of 2 divided by minus root of 2. And this is equal to pi over 4. But because our theta is in the third quadrant, it is actually equal to, so our theta is equal to minus 3 pi over 4. You get that? It's minus 3 over 4 because it's in the third quadrant. Okay, so therefore, we can write our u, now that we know its modulus r, we can write u is equal to, we saw that r is equal to 2, so it's equal to 2 e to the power minus pi over 4i. That's how u is expressed in exponential form, where minus 3 pi over 4, minus 3 pi over 4. Right. That is our complex number, u. Now the last part is a little bit tricky, but let's see how we can handle it. It says, find the 2 roots of u. Now let us suppose that w is equal to, w squared is equal to u, which of course means that w is the square root of u. Just like 4 squared is equal to 16, therefore 4 is the square root of 16. 6 squared is equal to 36, therefore 6 is the square root of 36. So we can say, let also, and this of course we know our u is equal to 2e to the power minus 3 pi over 4i. Let also w be equal to r-e, capital R-E, theta I, where theta would be the argument of w and r is the modulus of w. So what do we know? We know that w squared is equal to u. So r-e theta I all squared is equal to u. We can remove our brackets there and say r squared e to the power 2i theta, or 2 theta I is equal to our u, which of course is equal to 2e to the power minus 3 pi over 4i. Let's repeat our analysis here. We said w squared is the square root of u, meaning w squared is equal to u. Let w be equal to that, expressed in exponential form, where r is the modulus of w and theta is the argument. So it means that since w squared is equal to u, then this squared is equal to u. And this squared is that, which is equal to this, because that's what u is. So these two complex numbers are equal if and only if this is equal to that. In other words, the moduli are the same. So r squared is equal to 2, which implies that r is equal to the root of 2. The arguments should also be equal. This means that 2 theta is equal to minus 3 pi over 4. But remember also that if I have a complex number here, and that is its argument, let's call it what? Beta, let's say. If I turn 360 degrees, in other words, 2 pi radians, I will get back to the same complex number. So even if I turn any constant multiple of 2 pi, I will still get there. So if I have to add here a constant multiple of 2 pi, which is 2k pi. So let me write it clearly here and say 2 theta here is equal to 3 pi over 4 minus 3 pi over 4 plus 2k pi. This takes care of the fact that any multiple of pi will still give me the same angle there, the same argument, or the same complex number. So therefore, in exponential form, theta, of course, let's simplify first of all. Theta is equal to, let me write that first, that will be k pi when I divide it by 2 plus, when I divide this by 2, it gives me minus 3 pi over 8. Remember, the 2 comes over here. So this is the argument of u, of w. So I can write w as a function of k here is equal to modulus of w, which is root of 2, e to the power, brackets, k pi minus 3 pi over 8 multiplied, of course, by e. That is w expressed in exponential form. Do we get what we did here? Let's just slowly repeat it. We found that these two arguments should be equal. So 2 theta must be equal to this plus some constant multiple of pi or 2 pi. So 2 theta should be equal to minus 3 pi over 4 plus 2k pi, where k is an integer. So simplifying, bringing my 2 over to that side, I now have theta is equal to k pi minus 3 pi over 8. So I can now write my w in exponential form as root 2, which we found to be the modulus of w there, multiplied by e raised to that power, right? W is a function of k because it depends on what value of k we give. So the first root, of course there are 2 roots. The first root is given by k is equal to 0. So the first root will be w0 is equal to root of 2 e to the power, when k is 0, that will just be minus 3 pi over 8i. That's the first root. The second root is given by w1 when k is equal to 1, which is equal to the root of 2 e to the power. Well, when k is 1, we have pi minus 3 pi over 8. We put everything over 8. We have 8 here minus 3, which is 5 pi over 8. So it becomes 5 pi over 8i. These are the 2 roots of u. These are the 2 roots of u. And that answers the question on the complex number, question number 7. Beautiful stuff, isn't it? It's beautiful provided you just have to be very careful. This is one of those questions where on top of the need to have your concepts right, you are in addition burdened with handling rather some awkward numbers in the form of sets and so forth. That's where, if you're not careful, you can lose everything. You may get the principles right, but your answers might end up being wrong if you mishandle all these sets and these i's when you multiply out your brackets. That's the end. Till we see you next time in the next video. Thank you very much indeed. Please remember to subscribe and like our channel if you are happy with the delivery. Till next time, bye-bye.